Hello, everyone. My name is Eduardo Spotti, and today I take you through our journey designing and deploying a robust, scalable, and secure event driven platform using Apache Kafka on Kubernetes with the Strimzi at the core of the solution. This is not theory. This is a real system running in production, but still is a work in progress. We understand that is our solution. We always say that you need understand your problem and make the best solution that you want to resolve your problem. So um, we built this and processing over a million of event for per minute, spanning multiple teams, regions, and technologies behind these needs of the company. We'll dive into the architecture, tooling, problems we solved, and lesson we learned. All of this focused on developer autonomy, governance, and resilience at scale. So first, why choose event-driven architecture? So in traditional architectures, services communicate synchronously and often result in British change of dependencies. As our system scale, we need better decoupling or services, real-time responsiveness, and resilience. So, with an event-driven architecture, services publish and subscribe events asynchronously, and this gives us flexibility and replayability and allows each services to evolve independently, like microservice behavior. And Apache Kafka quickly became our backbone, but deploying and manage Kafka at scale is another challenge. And this is the reason that maybe where Streamsy changed the game. But event-driven architecture bring us all of these features like real-time, flexible decoupling, and scalability. And why we decide Streamsy as control plane? We check or we test different commercial solution, but Streamsy is open source projects. Streamsy community we help us a lot with different challenge that we resolve, and we understand that we use Kafka in the with all benefits behind Kubernetes. The lifecycle automation simplifies configuration, monitor integrates monitoring, and how? Well, StreamC operator provides native custom resource definitions (CRD) to declaratively manage Kafka inside Kubernetes. For example, Kafka object for cluster itself, Kafka topic for topics, Kafka user for access control. So this let us manage the opportunity to manage everything through GitHub's versioning, control, reproduce, and automated. We run this cluster with multi-zone deployment for high availability, with entity affinity rules to distribute, broker, and scale more in different tenants and other things. Our Stringy setup also integrate with Prometheus for metrics and Loki for logs. Very important. I talk about that late, but which fit all of this into dashboard and alert managed by a centralized SRE team. Also, rolling upgrade, certificate rotation, or and security update, all handled by the Streamsy operator. This is our first approach of solution architecture, but we encounter real world challenge in this case because developers need self-service tooling with guardrails like the primitive uh, reason to use platform engineer. We need the strict access control on Kafka topic across tenants and teams. We had to ensure schema compatibility and avoid runtime surprises, and we had to support multi-region replication and disaster recovery. In high level, we Kafka runs in EKS using the Strimzi operator, so giving us full lifecycle management of Kafka cluster. And we integrate, or we develop different Lambda function to primitive actions and in the platform. For example, create topics, create ACLs, and save this new metadata in DynamoDB. And we need a backstage in the front of developer internal developer portal, and different serverless step function lambda, all integrate to take different action in the solution. uh, in our example, to see backstage operate, we use step function to define the approval flows, because when developer need to create a topic or to subscribe to new topic, we need, in this case, just an action to approval this new subscriber to the topic, or new topic for a precise domain, new topic in a new domain of the business or of the hexagonal architecture that was the example of our customer. So we build a form through backstage to just justify and understand why these new services need connect to a topic. So this is one of the example of flows to build that. So was really challenged because we understand that we need that the streams have the control of the object, and this serverless development not take or not affect the mutability of the of the data. And we start to think what feature we need to understand that this is a really good event driven platform. And the first feature was schema management. Schema management, we use Apicuri registry. And well, why? We need enforced schema validation at the point of message production. We need support AVO and JSON schema. We need integrate with OAuth 2. And we need store schema in Kafka using internal topics for other reasons. Well, was really useful for us because client retrieved them by HTTPS using token from Cognito, and this help us to enforce security by design. Producers and consumer serialize and deserialize that auto validate against Epicure. Not we need develop any custom solution. And the continuous integration and continuous development schema changes are automatically tested for compatibility. Breaking changes are blocked before deployment. So our continuous deployment is very healthy in this part of the platform. The second feature that we need in this case a lot was replication data. We operate across multiple AWS regions, and we need to ensure data redundancy, resiliency, and latency optimized access. We use Mirror Maker 2 to replicate selected topics from Amazon MSK to our Strimzi on AKS. Authentication is done with OAuth 2, configured in both ways. And replication was selective and tenant aware. Not everything is mirrored. And we track replication lag using built-in metrics and expose alert via Prometheus. All of this with Mirror Maker and Strimzi. And this gave us flexibility, regional failover, disaster recovery, and localized data access for GDPR compliance. And it's also crucial for testing. Developers can replay production like traffic in non production without touching production services. So, this is the second feature that we define in the roadmap platform. The third that we need was understand that we don't need to rewrite our application to um, streaming data or replicate data. So we resolve the change data capture with division and streaming with Kafka streams. So in our use case, again, we don't need to rewrite our application. We just capture changes from database logs and convert them to Kafka events. uh, some or use cases detecting fraud by analyzing transaction stream, keeping caches and read models up to date, reacting to inventory changes in real time. So once in Kafka, all of this data, we apply stream processing using Kafka Stream to enrich events with reference data, join multiple streams, building materialized view. Um, Finally we adopt event sourcing and CQRS patterns in several business critical services, reducing the coupling and enable faster change cycles. Uh, and this was one of the best way to build this. So we understand that build this type of platform have a lot of challenge. We found this challenge by security, for example, reverse integration or auth by default. Some tools that we test not support or Kerberos or auth authentication. This happened with schema and replication. In example, Carapace is a schema registry open source, and we lack in the OAuth integration and schema validation controls that we need. So we eventually moved to Epicurus, and we made a major difference. In the case of Kerberos integration in the Mirror Maker solution, we we don't know or what happened with Cloudera, but Cloudera doesn't support Kerberos integration in their moment. I don't know if now is compatible, but in their moment, Mirror Maker doesn't work with Cloudera to replicate data. So we built some Lambda with Spark and different ways to connect to Cloudera and replicate data. But we use Mirror Maker for all of the rest of use cases, like MSK, K, with Strimzi cluster, the replication between them, and others data source in on-premise data center. And the other challenge that we found was how we define priority of features and on self-service way, and improve the developer experience, because all the squad wants the feature at same time. So we work to define the really first step. We found benefits and was be a challenge. Define that topic as a service is the first, because Kafka without topics doesn't work. And before we prepare the roadmap, thinking on the really needs of the business. So replication, so schema registry was the first. Um, then the change data capture and streams, and this work continue. The next step are event catalog, are event simulation, and new things around hexagon architecture, clean architecture, or different new patterns that we can find in our customers. And one of the new challenge that in this day we talk is planning migration to craft to simplify cluster management without Zookeeper. If you don't know, Zookeeper is cluster solution management between servers, and Zookeeper run additional things around the solution that is another thing to manage, and we want to reduce this overhead to the platform team. And some lesson that we learn, first, invest in observability from the start is obvious, but for us was difficult. Use a different solution in the customers, because each customer have different solution to observability. But we understand that we need see the behavior of the platform adoption, and not only the platform performance or platform healthy. So observability, like, okay, how much topics used by squad, by domain, by different thing that is more close to business metrics, is very useful to develop in the platform. Enforce schema compatibility. Data contracts are very important, like APIs contract, or any asset of technology that manage data in the company. OAuth 2 for us is the best fit with the platform for large scale access control. So, and was easy to integrate and to manage. And the other lesson was self-service is non-negotiable. So Backstage help us to scale the platform to more or less 20 teams, hiding complexity and providing safe abstraction. And this was a really good uh, work that we see in the internal developer platform metrics. And some results additionally from this journey, um, the end-to-end latency for messaging is improved by 40%. In comparison between Kafka clusters managed on the on-premise or cloud, in this platform, incident rate dropped by 70%. The throughput scale from 100 to over a million events per minute, and adoption grew very fast, over 300 microservices onboarded in the platform. So, well, I love share this with you. I hope that receive comment and suggestion and question from you by LinkedIn or any other social network. I hope listen more about this type of experience, and we are here to help you in any moment to found the best solution to build event driven platform engineer. So thanks for share your time with me today, and I hope to enjoy a lot this PlatformCon 2025. Uh, bye bye.